Greetings, children. I'm going to apologize in advance for my voice. Um, this is actually Mrs. Clisby, not Mr. Clisby, speaking to you right now. Tonight's video is going to talk about sequences, series, and sigma notation. Sometimes I use the terms sequence and series interchangeably, but there is a technical difference between a sequence and a series. A sequence is a pattern of numbers, or pretty much numbers, and a series is that pattern but with plus signs in between it. So, this is a sequence, and this would be the series, like that, okay? And so there's not really a big difference between the two. If you confuse the language, no one's going to get that mad at you. You probably understand. So really what we're going to focus on is sigma notation today. As you know, there is an operation, an exclamation point, which you know is called factorial, and it means 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's pretty nifty that we have an operation that tells us to do that. Well, wouldn't it be cool if there was an operation that told us to do that with numbers, with addition of numbers? And as a matter of fact, there is, and it's called sigma notation, and it looks like this. Add the series up. Okay? It's an operation. So, just to make sure it's clear that you understand it's an operation, this is a symbol you all are aware of. You recognize that one. That means add. Add the things on either side of that. Okay? If we have that, you know that this little house here is an operation, which means find the number that when multiplied by itself equals a. Find some number that multiplies itself to get a, the square root. Okay? We know that sine a is an operation which asks the question, given an acute angle in a right triangle, what's the opposite side over the hypotenuse? What's that ratio? So, therefore, if we saw something like this, this is an operation, and it tells us to do something. What it tells us to do is to find the sum of the series of f1, starting here, plus f2, f of 2, sorry, plus f of 3, plus dot, 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 all the way up to f of 10. This means find that, and then you would get a number here, or sum. Okay? This little operation would go away. You would use it up to add all these things, and then you'd end up with that. So that's what this big E, this weird-looking E, tells us. Okay? So we can call this sigma notation or summation notation. Okay? We can call it one of two things. Sigma notation, that's the Greek symbol for summation, which is the operation. Okay? So let's talk about how this works. I'll make a fancy one. Ooh, okay. So let's just write this thing out here. Okay, and I'm going to explain all the parts. This down here is called the index of summation. This basically says, where in the series do we want to start? Do we want to start with n equals 1? Do we want to start with n equals 2? And, which ones do we want to add? So it's possible that you want to add from the first one to the fifth one, but maybe you want to add from the fourth one to the 10th one or something. You could do that. So the index of summation is basically saying, where's your starting point? The k at the top is telling you the ending point, or the upper bound of summation. Okay? And this right here is going to be the rule that generates the series. Now, you may be thinking about some questions that you have already. Nicole and India, I know that you're thinking already of questions that you have, but I think that I will resolve them when I show you how to use it, okay? So don't panic. If you need to, you can go back and watch it again. Okay? I'm going to change colors now to just get you guys more alert. We're going to go with purple. Okay, so let's just make sure that you're clear on what I've said here about what this number means down here. So what this means is a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. Why are we stopping at a sub 6? Because that's the upper boundary. And this is our index, so this is where we start. Okay? So those are the terms that we add. It doesn't tell you how many terms we add. It says we start with the a sub n term, or the a sub third term, and we end with a sub 6. Okay? So let's do an example. All right, so this is the problem, and it's asking you to add the first, second, third, fourth, and fifth term generated by this rule and figure out what the sum is, okay? So I'm going to plug in 1, and I get 4 times 1 minus 3 plus 4 times 2 minus 3 plus 4 times 3 minus 3 plus 4 times 4 minus 3 plus 4 times 5 minus 3. Okay? So I've written this out now. I'm going to simplify it. So I end up with 1 plus 5 plus 9 plus 13 plus 17. Okay? I'm going to add these things together here. I get 18 and 18 and 9. 36 plus 9 is 45. So the answer to this problem, this is a problem, the answer to this problem is 45. Okay? Let's look at another example. If you want, after I write the problem, you can pause the video, try it on your own, and see how you do. Okay? So why don't you pause the video, go ahead and do that. Okay. So I hope you got 130, and I hope your work looked like that. Again, you can pause the video and check your work. Okay? Now, you should notice something about this rule here. This generates a particular kind of sequence. In this case, it's a series because we have plus signs. But you should recognize this, right? It goes up 5, 5, 5, 5. What do we call this type of sequence? That's right, it's arithmetic. And we know it's arithmetic also because this rule is linear. Does sigma only work with arithmetic sequences or linear sequences? Absolutely not. You can use any, the beauty of it is you can use any rule you want. Whoa. So let's look at another one. And let's start at n equals 2 and go up to n equals 7, and the rule will be n squared. So try that one on your own. Okay, hope you got it right. All right, so hopefully we know how to use sigma notation now. And now I want you to think about how you might put something in sigma notation, a sum in sigma notation. Okay? So let's say that I have this sequence here. Okay? Let's say I want to write this in sigma notation. If you'd like, you can pause the video and see if you could do it yourself. Remember that we need to figure out what we're going to call n. We need to figure out our rule in terms of n, and then we're going to have to figure out where we're going to stop. And then what we could do is we could check the whole thing and make sure that we get 3, 5, 7, 9, 11, 13. Okay, so I'm going to pause, no, you're going to pause the video and see if you can do that. Okay, so I hope that this is the one that you got. We identified this as an arithmetic sequence. The slope is 2 because it changes 2 every term that we have there, so that's 2n. We go back and find a sub 0, that's 1, so there's our rule. We're going to start at a sub 1. I mean, we could call that anything we wanted to, but why don't we just start at a sub 1 to make it easier on ourselves? So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6. So our upper boundary ought to be 6. And we could then check it and make sure. So let's just make sure like our 6th is actually 13. So we plug 6 in, we get 12 plus 1 is 13. That looks good. Let's see if our 4th is 9. So we plug in 2 times 4, which is 8 plus 1 is 9. So that looks pretty good. We did it. Okay. So these are kind of fun. We're gonna mostly what I'm trying to do right now is to get you comfortable with the notation here, so you know how to use it, and you would know, you know, what to do when you saw this thing. Because for most of you, I imagine this is new, and it's kind of a different language, and so you're just learning how to use this big monstrosity to do math. The last thing I will say is I hope that you've watched the video up to this point, because tomorrow we're going to have a quiz on arithmetic sequences and geometric sequences and sigma notation. So everything that you've seen in this video is fair game for the quiz on Friday, as well as the exercises that we did in class on Tuesday and the exercises that we did in class on Thursday. So the quiz will probably be about 30 minutes long. I will ask a couple of questions, or sorry, I will answer a couple of questions, maybe 10 minutes worth before I give you the quiz. But other than that, you know, I'm going to cut you off. So watch these videos again and again and do your review quiz to make sure that you know what you're doing.